So hey students, welcome to NCERT Solutions by Vedantu. On this channel, we find solution to all the problems which is given in your NCERT. This is Baswaraj, I'm your biology master teacher. Now, let's look at a question from the chapter Biomolecules now. What do the questions say? The question says, can you attempt building the models of biomolecules? They're asking if we can make buildings of models of your biomolecular compounds. It could be proteins, it could be different type of carbohydrates, mono as well as poly, using commercially available atomic models, that is ball and stick models. So you might have observed this ball and stick model in the chemistry, and we find so many different compounds, we make so many different compounds using the structures of such as your ball and stick. But can we implement it in biology, that is in biochemistry? The answer is yes. Yes, we can make the 3D structures using the ball and stick model. So what is exactly is the ball and stick model? First, let me just write down here. Ball and stick model is 3D visualization. Ball and stick model is the 3D molecular model. They are the 3D molecular models. Now, using this 3D molecular models, we show visual representation of how model can look in a 3D space. Because when you write down the structure of a molecule, it usually shows in 2D format when you write in the book. But if you really want to understand the spatial arrangement of it, you need to make a 3D model, that is a ball and stick model. So in your biology, that atoms, not just biology, even in chemistry, atoms are usually represented as balls, while the bonds, right, the type of bonds present between them, they don't show type of bond, but they show bond. The bonds are usually represented with the help of stick. So that is the basic arrangement. Now let me quickly tell you, let me quickly show you, actually let me quickly draw and show you one of such models. So let's take the most simplest biomolecule in entire of your biomolecule chapter, that is glucose, right? Let's make a structure of your glucose. Let me change the color to white. So here I told you all the atoms are represented as balls. So we have your carbon atom here, followed by your one more carbon atom, carbon atom, carbon atom, C6, right? C6. So 1, 2, 3, 4, 5. One more. 1 second, students. Let me. Okay, it's fine. I think we can manage here. The space is enough. So C6, 6 carbon atom. Now this is the lines. Can you see these are the sticks? Sticks are the bonds here. The sticks are the bonds here. But then we also have the carbon atom, which are the represented as balls here. Then let's try to add in the oxygen. Let's use red for oxygen, right? Red for oxygen. We have an oxygen here. We have an oxygen here. Let's draw a structure here. Then we also have oxygen here. Then we also have one more oxygen here. Oxygen. Then we have one more oxygen here. Then we skip, and then we have one more oxygen here. So this is your oxygen. Now let's try to fill in the hydrogen. Let's use blue color for hydrogen, shall we? Blue color looks more pretty on hydrogen because hydrogen representation is usually blue color, because hydrogen, dihydrogen oxide, that is your H2O, right? So let's write it as here. Let's try to fill it up. Hydrogen, hydrogen, 1, 2. Let's try to fill it up. Hydrogen, 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 as well as hydrogen. So this is a ball and stick model. Let me try the ball. Wait, now it totally becomes ball and stick. So this is the ball and stick model of your glucose, D-glucose. So yes, in every other biomolecule can be represented as a ball and stick model, and I'll see you in the next class, students. Take care, all of you.